dx is equals to y square over y plus 5. No x's, please. So what we do, we transfer the y's to the left hand side and x's to the right hand side. Let's assume there is a 1 here, right? So it's a 1 times. So it's a 1 times dx. Take that there. Transfer the fraction. That should be upside down, as you know. Y plus 5 divide by y square and dy, please. Sorry, that's a dy. Integration on both sides. Split that, right? You know how to integrate these expressions. We have y over y square plus 5 over y square, and integrate. Dy is equals to x. Then that's actually 1 over y, so you get natural log y, and this is 5y to the minus 2, please. So that's going to be 5y to the minus 1 divided by minus 1 after the integration. So this is natural log y minus 5 over y is equals to x. You can leave the answer like that. So x is written in terms of y. Up to now, we used to write y in terms of x. This is x in terms of y. That's all. So we did the first bit now, right? Where one side is always x, or maybe the last sum we had only y. We transferred the x and y's on both sides now, because that's the second part where your question will have x and y both. Okay, that's here. Dy over dx is equals to x over y. That's the first question. We have both letters here. Let's transfer the y to the left hand side. So denominator becomes numerator. Y dy is equals to x dx. Looks pretty nice. Then just integrate on both sides, right? That's a y square divided by 2 and equals to x square divided by 2 and plus c. If you need to get rid of those 2's, watch there, you need to times by 2, times by 2, times by 2. So we have y square equals to x square. 2c is also a kind of a fixed number. What's that c means? We all know c stands for the word called that. It's a fixed value. So if you multiply a fixed value by a 2, you get another fixed value. So let's call it as a or p or q. So y square equals to x square plus a. When a becomes a 1, you have one type of curve. When a becomes a 2, that's the curve will change. So this is actually a family of curves. If you use the autograph and draw these curves, you get beautiful shapes. All right. Then the second one, similar type, but it's a y over x. Copy that, please, and solve that. Transfer the y to the left hand side. So that's going to be 1 over y dy equals to 1 over x dx. Right? Then integrate on both sides. We know this is natural log y, modulus, please, equals to ln x modulus and plus c. You can write c also as ln c, nothing wrong. But for the time being, we leave it like this, okay? So that's the general solution. But if the examiner wants you to express the answer as y equals to, then you can say, keep the y there is equals to, transfer the ln, it becomes e to the power, that top one, which is ln x there and plus c. Simply simplify this a little bit further, see what happens. This is actually e to the ln x, right, and plus becomes a times e to the c, right, basic exponents. Now e to the c is another fixed value, so call it b, right? So it's b times e to the ln x is nothing but x, so it's b times x. All right, so those rules you all know, isn't it? That's all. So the answer is now y is equals to bx. Do you agree that's a straight line, isn't it? So b can change as 1, 2, 3, 4, 5. So you are looking at straight lines passing through the center of the curve depending on the value of b. So they are family of curves, and that's the general solution. Okay, next type. So they actually tell you a family of curves and how they look like, and they form beautiful figures when you actually check the graph, right? We have next question here, number 3. Try that, please. The questions become a little bit longer as we go ahead. dy over dx equals to xy. So keep the x there. Dx will move to the right hand side. So it's called separation of variables. That's what your textbook says. Moving y and dy one side. So it's 1 over y dy is equals to x dx. Separating the variables, then integration on both sides. So we have natural log y, right, inside the modulus is equals to half x squared and plus c. Okay, make sure you make y subject, right? So we have y equals to e to the power, that whole thing, which is half x squared and plus c. Once again, please don't forget to split this a little bit more. See how it is done. E to the half x squared stays there, plus becomes a times and e to the c, isn't it? If the bases are same, we add the exponents and we get that step. Now e to the c is a new fixed value, so let's call it as k. So it's k times e to the power half x squared. So that's all, and that's y is equals to. That's number 3. Then try a few more. Yes, I think before we do the major ones, let's practice a few sums, please. Question 4 is on the screen. dy over dx plus y square equals to 2xy square. We got to have all the y's at one place, all x's on one side. Let's transfer that first so that we can make y square subject, right? So dy over dx is equals to 2xy square minus y square. So what we do now is we just make the y square subject. So we have 2x minus 1. So we separated the x from y. Now it's easy to transfer the y to the left hand side. So dy over dx equals to that, right? And transfer the y square to the left hand side. So it's 1 over y square, and dy stays there, which is now equals to 2x minus 1 inside the bracket and dx. That's nice, easy to integrate. So integration, left hand side and right hand side, please. So what we have, 1 over y squared, that becomes y to the minus 2 on top. So we know that's y to the minus 2 plus 1, so it's y to the minus 1. Divide by minus 1, so that's minus. Equals to, that's going to be 2x squared divided by 2, so x squared and minus x. Plus c, please. This becomes actually minus 1 over y. We know if you need to make y subject, you need to do that. Okay, don't leave the sum there. How do you make the subject? Transfer the minus here. That becomes a minus there, right? Flip this, so we get y is equals to minus 1 over x squared minus x plus c. Okay, so you can leave the answer like that. So that's one type. If you don't already have the x and y separate, do some kind of algebraic manipulation and move them around. Question 5, try this, please. Copy that down first and solve it and see what you get. dy over dx equals to xy minus x. Separation, shall we take x common there? We get y minus 1, agreed? And left hand side dy over dx. It's easy now, so keep the x there, dx will move, and move the y minus 1 to the left hand side, so it's a 1 over y minus 1 and dy. Integration on both sides. 1 over y minus 1 natural log y minus 1 modulus equals to half x square plus c. Once again, please listen, make y subject unless the examiner asks you to leave in this fashion. So y minus 1 is equals to e to the power that half x square plus c. And use the exponent loss there and say e to the half x square multiplied by e to the c. And then move the minus 1, it will be a plus 1. So the new fixed value, that e to the c, name it in a, say, use another letter. For example, say m times e to the power half x square and plus, sorry, this is 1 here, plus 1 please. That's a plus 1. Okay, so y equals to m e to the half x square plus 1. So we only found the general solutions. We are not finding the exact value of c yet. That we will do in a minute. Right, sixth question. Try, that looks big, isn't it? 3x times, we have dy over dx and 2y plus 1 x plus 1. That's a y term, that's a x term. Right, let's move that to the right hand side, see what happens. I'm just keeping x plus 1 there. Divide by 3x and dx comes there. You all know how to move things around, right? So it's a 1 over 2y plus 1 and then dy stays there. That's it. We integrate on both sides. That's with respect to y, with respect to x. 1 over something, there's no square cube, so I can say that's natural log 2y plus 1, isn't it? Is equals to x plus 1. So let's split that. It's x over 3x, right? Let me write there. So it's 1/3 and plus 1 over 3x. So that's what we integrate, and we are supposed to get 1/3 x plus 1/3 natural log x, please, modulus and plus k. Okay, we can leave it like this or make 2y plus 1 subject, right? Then you have e to the power blah blah blah. You can put e for each one of them as a times sign. That's it, right? So if you want to just extend this to c, let's struggle a little bit there. 2y minus 1. Right, so let's write 2y. Hey, I think we made a small mistake there. Reverse of the chain rule. So it's a half there, please. Watch out. So it's a half times this. Times by 2 on both sides first. So we will have natural log 2y plus 1 is equals to 2/3 of x plus 2/3 of natural log x, okay, and then plus 2 lots of k, so call it a, right? It will change, 2 lots of k, you can call that as a. Now you can keep the 2y plus 1 on left hand side and transfer the whole thing. 2y plus 1 is equals to e to the power blah blah blah, then write them as e to the 2/3 x times that, okay, and in the end transfer the 1 and 2. Algebra you all know, but this is just the method. Okay, so I will leave this question there because we have lots and lots of sums to go. This is one of the exam questions actually. Minus 15 dv over dt, that's a rate of change of volume, right, is equals to 2v minus 450. They want us to solve this differential equation, the general solution only. Right, so shall we move? Well, in this one, there is nothing we can do. Maybe if you take a 2 common there, we have v minus 225. Right? Okay. So I'll keep the numbers on the right hand side. So I have 2 divided by, say that's a minus. I'm moving this here, 15. Move the dt there, done. Then this bracket take it to the left hand side. So that's a 1 over v minus 225 and dv. All the v terms there, dv, and numbers there, dt. If you don't want to take the 2 as a common factor, it doesn't matter. Now, integrate on both sides, right? So it's a 1 over v minus 225 is a natural log v minus 225. Done, is equals to minus 2 over 15 t. T is the time, and plus c. If you would like to make v subject, right, let's do that. V minus 225 is equals to e to the power, that whole thing, minus 215 and a t there, that's a 5 please, and plus c. Split that, so it's e to the power minus 215th t and e to the c, right, and transfer the minus 225 to the right hand side, plus 225. That's what you call as v. Just be careful, change that as a new letter, call it a maybe. So it's a times e to the power minus 215th t and plus 225 is the volume at a given particular time. Okay, that's the general solution. We have question 8 here. X square minus 1 dy over dx is equals to x and y there. Maybe we are in partial fractions or not, we don't know yet. Let's see. I keep the x there, divided by x square minus 1. Yes, we are in partial fractions. 1 over y or not, no, dy. Integrate, done. That's a dx please. That's a guessing style, right? If you differentiate the denominator, you can get the numerator. Just a 2 is missing. So substitute a 2 there and a half in front. So right side actually becomes 1 over 2. That's ln x square minus 1. Correct? Left hand side is natural log y. That's all. Modulus please. And plus k. Make y subject. Do you want to do that? So we can take the half to the top. So we have natural log x squared minus 1 under the root and plus k, and this is ln y. As long as you know how to manipulate and get that y out, it will be great. So we have y equals to e to the power natural log x square minus 1 under the root and then plus k. So that becomes times now, as you know, so that's e to the power k like. Okay, we did that in the last lesson, last sum. Change this to a new letter, call it w, fine, doesn't matter, times e to the power ln x square minus 1 under the root. Okay, that's the final equation as y equals to. Right, we did 8 questions up to now. The 9th one is on the screen. Remember, these are first order differential equations. We are finding the general solutions only. Initial conditions are coming. Now, dy over dx equals to e to the x blah blah blah. So this we can move to the left hand side. Okay, we have e to the x dx. That seems nice. This is 1 over 1 plus y square. Oh, this is a little bit, we need to think about this question. How do we integrate this? Means, as I said, we need to know all types of integrations before we come to learn this topic. You can solve this by substitution method. Okay, so it's 1 over 1 plus y square. Now, how do we integrate this? That's very important, right? We have to look at the substitution method. So I'm going to solve only this. I will leave that for the last step, right? So if I choose, say, let y equals to tan theta, suppose, and differentiate that on both sides. So this is the integration by substitution, please. dy over d theta equals to sec square theta. Let's make dy subject, right? Dy equals to sec square theta d theta. So that's what we are going to substitute here, and that becomes 1 over 1 plus tan square theta. Okay, see what happens, right? So I'm leaving this please. I'm just solving only that here. Watch. So we have integrate 1 over 1 plus tan square theta. Dy is actually sec square d theta. So that's a sec square theta d theta. So 1 plus tan square theta is nothing but sec square theta. So those two cancel out. We got 1 d theta. That's the integration for that by substitution method, right? We need to integrate this. So integration of 1 with respect to theta is just theta. Okay. So this theta is the answer for that. So let's write that down and say left hand side is theta is equals to right hand side integration of e to the x is e to the x plus c. But our question is actually in terms of y and x. So finally the general solution should be y equals to, right? So somehow we need to make theta and make it look like a y. So if you go back there, tan theta is y, right? Let me write here, tan theta equals to y. If you make theta subject, that should be tan inverse y, okay? Tan becomes tan inverse if you move that to the right hand side. So let's write that down and say, right, theta is equals to tan inverse y equals to e to the power x plus c. Now we need to make y subject. So in the end, keep the y here. When you transfer the tan inverse, it becomes tan. So that's a tan inside the bracket e to the power x plus c. So that's the final general solution written as y equals to blah 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 in terms of x only. So just be careful. All different types of methods play an important role. Okay, that's the question 9, right? We did this by substitution method, please. We got one more that is here. That's 10th question. Cos square x dy over dx equals to y square sine square x. Nice. Sine square and cos square, we can move them to one side, right? Sine square x divided by cos square x, and dx also moves to the right hand side. Left side we can move the y square, so that's a 1 over y square dy. All right, that's it. So right hand side looks a little bit smarter. That's a tan square x dx. Okay, left hand side is 1 over y square dy. Now let's integrate on both sides, see what happens. So integration, that's y to the minus 2, as you know, minus 2 plus 1. So y to the minus 1 divided by minus 1. That's what I have, minus y to the minus 1 equals to integration of tan square, right? We cannot integrate tan square there. We know the rules. Sec square theta integration is tan theta. So let's write this in terms of sec square. So 1 plus tan square theta is sec square theta. So that's a sec square x minus 1 dx. So now we are able to integrate this. Integration of sec square theta is a tan theta or tan x minus 1 is just x plus k. Left hand side is it's 1 over y, okay, minus. Again, you can remove the minus sign and make y subject in the end, but that's the method. Okay guys, just be careful there. The tan square, change it into sec square minus 1. So you can finish that, right? The 11th question is here, e to the x plus y dy over dx. X is here, 2 plus e to the y. So I have a y here, I have a y there, but somehow I need to bring all y's to one side. This is exponents rules there. So can we write this as e to the x times e to the y, that is same as e to the x plus y. So that's all. So the y and y, we can move them to one side.